To begin the meeting, I would like to invite Mr. Pradeep Chaturvedi ji, FNAE Chairman, INAE Delhi Chapter, to give the welcome address. Over to you, Mr. Chaturvedi.
Thank you very much. Good morning to everyone, and welcome to this seminar on green hydrogen, which is being jointly organized by International Solar Alliance and the Indian National Academy of Engineering. Shri B.S. Bhalla, Secretary MNRE, and the Chief Guest, we are indeed grateful to you for your finding time, and Professor Manna, the President of the Indian National Academy of Engineering, Dr. B.N. Suresh, Dr. Sanak Mishra, the former presidents of the Indian National Academy of Engineering, Shri U.B. Desai, Professor Shivaji Chakravarti, and Shri J.D. Patil, the vice presidents of the Academy, and Dr. Anil Kakotkar, who will be delivering the keynote address, and the past president of the Indian National Academy of Engineering, and all the expert guests. I have great pleasure in welcoming you on behalf of the INAE and the ISA for our distinguished experts and participants to the inaugural session of the seminar on green hydrogen. My special welcome to experts who are joining us virtually from different continents after adjusting the time frame. The Academy has been established to be a peer organization composed of the best talent from the entire spectrum of engineering in the country to promote all-round excellence. ISA supports its membership in accelerating energy transition through solar energy and its derivative applications against the backdrop of global momentum for green hydrogen as a viable energy transition vector. The ISA has launched a dedicated program, Solar for Green Hydrogen. Following the outcome of G20 summit, it was considered appropriate to take specific steps in promoting hydrogen energy. A seminar was jointly organized by INAE and ISA. The outcome from there pointed to certain actions. This sequel seminar has been organized in the same spirit and will focus on green hydrogen, the relevance, policies, standards, and regulations. Second, the economics of green hydrogen in Indian context. Third, the demand creation for green hydrogen in the Indian context. Dr. Ajay Mathur will discuss in detail on what we wish to elaborate in these sessions. Let me also say that INA has already played an important role in focusing on decarbonizing industry and identifying potential for use of hydrogen in different scale. Being a partner in the global report published by Cates 2 years back, our intense proactive follow-up on hydrogen energy after the G20 summit also reflects our commitment to identifying the cost-effective technologies, skilling manpower, and suggesting the appropriate ecosystem. Let me assure you, our Chief Guest, Mr. Bhalla, that we had been very keenly involved for the last about 10 years on renewable energy technologies, how to go ahead. Every time we were just trying to find out what can move forward, in the 3 reports that we had published have all led to very useful and purposeful discussions at national and the international levels. And therefore, we are very hopeful that we will be attaining a report out of it which will be of use to the national policy making. And with these words, I thank the organizers, and I'll leave it for Mridula ji to take over.
Thank you, Mr. Chaturvedi ji. I would now like to invite Professor Indranil Manna, FNAE, President of the Indian National Academy of Engineering, to give the opening remarks. Over to you, Professor Manna.
Thank you very much. Mr. Bhupinder Singh Bhalla, Secretary MNRE, Dr. Ajay Mathur, DG ISA, Dr. Anil Kakotkar, former President INAE and also the keynote speaker today, former presidents of INAE, Dr. Mishra, Dr. Suresh, my colleagues in INAE, the vice presidents, colleagues, and friends who are participating in this very important event. We are all aware that life doesn't exist without energy. So there's no further need to underscore the importance of initiatives on energy. But we are talking about hydrogen as a source of energy. The world over now, there is an increasing realization that we not only need to harness energy, we need to also do it such a way that we don't imperil the Mother Nature anymore. So there's a huge emphasis on renewable resources, and we do have options in the form of solar, hydro, geothermal, and many other processes. We also in this country are fortunate to have capability of harnessing atomic energy to a large extent, but for whatever reasons we do not harness to the extent desired. It's not really, not yet double digit. In this backdrop, we have set up before us a target that by 2030, India will have almost equal or even slightly more than the current capacity of energy generation through green hydrogen initiative. This certainly is a very, very tall order that we are talking about, but I hope that under the leadership of MNRE, all ministries, all research institutions, industries should come together and make it possible. At the moment, we generate somewhere around 400 gigawatt hour of electricity. I'm talking about generation. We lose quite a lot of it through transmission. But to use hydrogen as a green source, harnessing it through a green, which means we are using probably solar or some other renewable resources to generate, and then make it or use it effectively to generate energy, there are a lot of engineering and technological interventions. As I often say, that from know why to know how and eventually to know what sells, that means to reach ultimately the technological success platform, it is not an overnight task. Coupled with the fact that hydrogen is the smallest molecule, highly diffusive, permeating, inflammable, even combustible in presence of oxygen, makes it very difficult to store, to transport, and then eventually harness. So to reach to the target of 450 gigawatt in just about 5 or 7 years is certainly going to be a very, very difficult task. But engineering is meant for providing solution, and these solutions has to be feasible and viable. So we have challenges in front of us in the form of high capital cost of investments, requirement of large and new infrastructure, availability of water which actually can be split to produce green hydrogen, availability of renewable energy to split hydrogen, and associate technological challenges. So we need government intervention, and that is exactly why the National Green Green Hydrogen Mission has been launched. So I'm sure the government already is thinking, and possibly will hear from Secretary MNRE, schemes, various incentive schemes, various infrastructural developmental plans that we need to have in this direction, R&D initiatives and support towards that, partnership with industries, particularly private sector investments and involvement, and at the same time water conservation, because water is another resource without which life doesn't exist. So we cannot afford to create one solution and imperil the remaining or existing solutions available. Transmission, as I mentioned, also is another major concern, that you produce, you generate, and then while transmitting, you cannot afford to lose 1/3 of it. So the National Green Hydrogen Mission, which was launched on 4th of January 2023, needs to be taken forward. And it's heartening to see that the government has already pledged to invest 8 lakh crore by 2030. Now, to have a budget is one thing, and to be able to fruitfully utilize is another very important thing. And in this count, I think Indian National Academy of Engineering, with the best of the talents in the engineering and technology pool throughout the country, drawn from industry, academia, and R&D organizations, possibly can play a very major role to augment the initiatives of the government. In fact, INAE recently organized an event steered by the National Chemical Laboratory in Pune. In fact, Dr. Ashish Lele is going to speak also in this very event, which was a bilateral program between INAE and Royal Academy of Engineering UK. And the theme was exactly green hydrogen. One of the international, very well-known international experts, Professor Nigel Brandon, was the counterpart, and we had very fruitful discussions in that. In our last annual convention in Bhubaneswar, one of our very eminent fellow, Professor G.D. Yadav, spoke on green hydrogen initiatives in the country, summarized and gave us a very nice overview. Similarly, INAE has held brainstorming sessions on innovative pathways for hydrogen development on 17th November 2023, in which Dr. Mathur was a key person, and Dr. Kirit Parikh, former member Planning Commission and former chairman IRADE, spoke. So I would like to assure the audience and certainly MNRE and the key players in this field that Indian National Academy will never be found wanting if we are given an opportunity to place on the table our strength and augment the initiative of the government. I think I won't take any further time. Thank you very much for giving me this opportunity to speak here, and I look forward to the deliberations that will follow. Thank you, and Jai Hind.
Thank you, sir, for summarizing all the salient points related to the GH sector and energy in general. I would also like to mention that this event is live telecast to all our registered online users across different ISA member countries. And this is through the INAE WebEx platform. Ladies and gentlemen, Dr. Ajay Mathur, Director General, International Solar Alliance, will now address the gathering to provide the context and objective of this seminar. Over to you, sir.
Thank you. Thank you very much, Madhura. Honorable Chief Guest, Shri Bhupinder Singh Bhalla ji, Professor Indranil Manna, Mr. Pradeep Chaturvedi, session chairs, all the former presidents of INAE, vice presidents. Such a pleasure to welcome all of you here. We are delighted to host this meeting together with the INAE. INAE, obviously, as Dr. Manna said, promotes the practice of engineering and technology and their applications in solving problems of national importance. We also note that today was the foundation day of INAE, and on behalf of ISA, I extend my warmest greetings to INAE. We follow up on the challenges in the deployment of green hydrogen, which, as Dr. Manna mentioned, was held in November last year, which focused much more on the supply side. This time, we are focusing much more on the demand side. Obviously, we need clean energy, and we need it yesterday. Why are we not moving towards green hydrogen? The key issue right now is cost competitiveness. Green hydrogen costs much more than grey hydrogen, which is obtained by the reformation of natural gas. We need to quickly move ahead, bring down the prices of things like the electrolyzers that are used to split water through using green electricity to make green hydrogen, to move up on the thermal side so that energy from nuclear plants can be used for splitting water. It is these kinds of interventions which would lead to the cost of green hydrogen becoming cost competitive. 2023 was a marquee year for green hydrogen. There was a huge amount of discussion and investments in green hydrogen. At ISA, we set up the Green Hydrogen Innovation Center, and we also set up, under Mr. Bhalla's leadership, the ambitious green hydrogen mission, which has very, I would say, challenging green ammonia targets. Now, we obviously are looking at actively looking at how hydrogen can help in decarbonizing the hard-to-abate sectors. Hard-to-abate sectors are those sectors where it is difficult to use only green electricity. So you need a thermal fuel, whether we are talking of chemicals, whether we are talking of fertilizers or steel or cement or oil refining. In all of these, it is seen that green hydrogen could play a key role instead of various existing thermal fuels. But R&D is important to make these changes happen. We note that a Norwegian company, Norsk Hydro, recently achieved a significant milestone by producing the world's first aluminum using green hydrogen. We are particularly concerned at ISA about the fact that we have very little renewable energy and green hydrogen investment occurring in Africa, which is the place where there's an abundant solar energy available. There is a significant competitive advantage, supplying it at a global scale, yet we see that not happening. All of this said means that we need to have an appropriate definition of green hydrogen. What is green hydrogen? How much carbon dioxide can be emitted? In the long term, we look at it as zero, but how do we progressively look at it? We right now have a goal of 2 kilograms of carbon dioxide per kilogram of green hydrogen. How do we look at reducing it and achieving a global agreement on this? Second, we need standards. You will remember, many of us who went to engineering school at the same time as I did, that hydrogen was taught to us to be the most dangerous gas. It was said that you could walk into a hydrogen fire and not know it because it's invisible. We have been successful in managing it at an industrial level. We also need to make sure that the processes are in place so that it can be used at the retail level, much like LPG is used today. Third issue is that of guarantee of origin. Where does this come from? What is the chain regarding ownership, so that you can follow up a kilogram of hydrogen and see that it came from a green source. All of this means that we need to have national missions, strategic partnerships across countries and across companies. Countries need to enhance regulations, but most importantly right now is the need to provide access to low-cost financing. Low-cost financing is important because as far as green hydrogen is concerned, the vast amount of investment is upfront, and therefore the cost of financing matters. At ISA, we launched the Solar for Green Hydrogen in our 4th assembly in October 2021, and are now providing support to various countries in developing roadmaps on doing green hydrogen. Last year, as I mentioned, we launched the Green Hydrogen Innovation Center, and under the Green Hydrogen Innovation Center, next month, you will see a workshop in Sri Lanka for the South Asia region on safety and technical aspects of using hydrogen. And then you will also see in this year 2 workshops, one in Delhi for the Asia Pacific region, and then 3 more next year in the LAC and Europe region for the green hydrogen utilization and policies that help green hydrogen take off. We Note that these activities build on each other. Mr. Chaturvedi mentioned to me that at the end of this week we will be looking at technologies. I believe that the hydrogen technologies that we talk about today could be some of the key areas where INAE could focus on. I would also like to mention that together with the Asian Development Bank and funding support from NADO of Japan, we had launched a report which was released at COP27, which focused on a framework for green hydrogen development and a readiness assessment for the Asia region, for the Asia members of the ISA. We are now conducting a deep dive for Brazil, Chile, and of course for India, along with technology assessment for electrolyzers and presenting an in-depth review of existing green hydrogen standards for the electrolyzers. We are currently doing this for 10 other ISA member countries as well. We now are looking at seeing how we can enhance the ecosystem for training. I mentioned some of the training programs that will be held. And the third part is bringing together developers and users and financiers, in a sense, carrying out the matchmaking within the auspices of the Green Hydrogen Innovation Center. The Green Hydrogen Innovation Center is led by a high-level steering committee, which provides executive insight, and I thank our member countries, India, Australia, Spain, Denmark, Morocco, Egypt, Chile, and Brazil. And this is inclusive, it is on a rotating basis. We also have partners like the ADB, the World Bank, the West African Development Bank, NREL, IEA, and the private organizations like Siemens, Greenstat, Green Hydrogen Organization, HDF Energy, Tata Steel, NTPC, to help steer the agenda of the Green Hydrogen Innovation Center. We look forward to collaborating more with the Indian National Academy of Engineering and with other organizations across the world to move us ahead towards green hydrogen. I would once again express my sincere thanks to our chief guest, Shri B.S. Bhalla, Secretary MNRE, for joining us at this seminar, and also thank all the other speakers and online participants for joining. I look forward to both a stimulating and informative discussions in the minutes to come. Thank you very much. Mridula, back to you.
Thank you, Dr. Mathur, for setting the context of this meeting. Ladies and gentlemen, it's an honor to have Shri Bhupinder Singh Bhalla, Secretary, Ministry of New and Renewable Energy, Government of India, as our chief guest today. Sir, could I request you to kindly deliver the inaugural address? Thank you.
Thank you. Good morning, everyone. My colleague, Dr. Ajay Mathur, Director General, International Solar Alliance, Professor Manna, President of Indian National Academy of Engineering, Mr. Pradeep Chaturvedi, Chairman, INA Delhi Chapter, Dr. Kakodkar, all the eminent members of INAE, and all the other delegates who have joined us today. It's a pleasure to be here today. When I received the invitation from Dr. Mathur for this seminar and I became aware of it, I think it was an automatic choice to say yes. He wanted a confirmation immediately. I said, of course, because the Ministry of New and Renewable Energy that I had as secretary has pioneered the National Green Hydrogen Mission. We launched it in January last year, as was mentioned by Professor Manna. And I think it is our responsibility as the Ministry of New and Renewable Energy to steer the mission in the way that we want it to go. green hydrogen produced using renewable energy, and we have, of course, several colors of hydrogen. We in India are focusing on green, and we have, and our definition of green hydrogen is very simple, that it must be made from renewable energy. That's the core, essentiality. Second, of course, is the standard part, which Dr. Mathur also mentioned, that how much of carbon emissions is possible if you want to call it green. And he mentioned in our standard that we have formulated in consultation with the industry. It's not a standard which has only been, worked on and formulated in the consultation with scientists or within MNRE or otherwise. We have consulted the industry, we consulted the technocrats, and then we came up with the definition of 2 kilogram, which we feel India has the capability to fulfill when we, to make green hydrogen on that basis. As far as the, as the global consensus towards net zero is gaining momentum, the demand for green hydrogen and its derivatives is set to rise. And green hydrogen, as was mentioned, has this very, very specific characteristics which make it very difficult to handle. And not only in storage, transportation, and of course production. So therefore it is quite obvious that green hydrogen is likely to be converted to other derivatives, because then makes it easier to utilize, easier to transport, easier to store, and so on and so forth. However, we do expect both things to happen. We expect, of course, green hydrogen to be produced, and then we expect most of it to get translated into its derivatives. But we will still have green hydrogen as green hydrogen, which is going to be utilized directly. It's the asymmetries in the demand and supply across the world, in the production capability, the space which is required for the renewable energy part. Essentially, production by itself does not need too much of space, but if you're going to power the electrolyzer with RE, renewable energy, then that RE needs a lot of space. It's either solar, wind, or whichever RE that we're talking about. So that availability of space, and of course other aspects, therefore are likely to limit the production of green hydrogen across the world to limited territories. It's not going to be there everywhere, not only from the possibility of space constraint, and also the economic viability of it. And therefore I think it's a very big opportunity for not only India but other countries which are likely to excel in producing green hydrogen. I think there will be several opportunities for export purposes across the world. Not only, and mostly the export is likely to happen in the form of green ammonia or green methanol rather than green hydrogen, for the reason that I mentioned earlier. The mission that we have launched last year is about 20,000 crore, 19,700 crores, so about $2.5 billion roughly. The aim is to make India the global hub for production, usage, and export of green hydrogen and its derivatives. Now there are several, and we call it the mission, and the reason we call it the mission, let me just briefly mention that. It's a mission approach. India has been setting goals in a mission-oriented approach, and we have been successful in the mission that we have launched. So one, it is a mission because we have a specific target to fulfill. We want to achieve 5 million metric tons of green hydrogen production capacity in India by 2030, and that's the minimum kind of a thing. That's one. Second is, mission is also inter-ministerial. It's a multi-ministry approach. Multi-ministries, so many departments. It's a whole of government approach for making it successful, and that's the reason we also wanted to call it a mission. And third, of course, is mission, and this, it's not only easy. It's very easy to say that we want to achieve 5 million metric tons of green hydrogen, but if you work out the details, there's so many components which we need to target as part of the mission, and that is why, again, it's a mission, because there is so many things that we have to do. All those boxes must be ticked before we to enable us to be successful. And it's not only for India; it's elsewhere in the world. Anybody who wants to do it is looking at these aspects as well. One is having electrolyzer manufacturing in India. You can set up production capacities, but if the electrolyzer manufacturing is limited in the world, globally, now new capacities are coming up across the world, but again, that is going to be limited. So going forward, if you really want to make India a global hub, we need to have electrolyzer manufacturing in India, and therefore we need to have incentive. Second, as Dr. Mathur also mentioned, we need to incentivize the production of green hydrogen, and therefore we have an incentive under the mission to encourage green hydrogen production. Our incentive that we have is also a little different from some countries, how the other countries are doing it. We have an incentive for production. We do not have an incentive for utilization. And that is important from the aspect you mentioned in what you're going to discuss today. So our incentive is focused on lowering the cost of production so that it becomes easier to somebody to buy it. We do not have any incentive for utilization, zero. So that's the second part. Other components of the mission, again, which is going to make it, which are very important to make it successful, is the R&D. Dr. Mathur mentioned about the economic viability part and how we have to reduce the cost. 70% of the cost of green hydrogen is going to emanate from the renewable energy aspect, is the RE aspect. So therefore, how can we reduce the cost of renewable energy, the price of renewable energy? And number two, how do we improve the efficiency of the electrolyzer? If currently the electrolyzer is taking 55 units of electricity, kilowatt hour per kilogram of hydrogen as a standard that we have, current standard, can that 55 come down to 54, 53, 50, 45? And if you can brought down from 55 to 50, you're chopping off literally 10% of your cost of renewable energy. So from 70%, that's how you are going to target the lowering the cost. 30% is other aspects as well, which is the other costs for production. But 70% is a big part, and therefore it's important to have R&D to do better, to make better electrolyzers, to improve the efficiency, to use technologies, to look at the present technologies. You have, of course, alkaline electrolyzer, you have PEM electrolyzer, then you have the solid oxide, new SOEC electrolyzers are coming in, the new, still not commercially available, but yes, and the new technologies will emerge. How do we bring new technology to the electrolysis process? That's as simple. In fact, I believe there are other ways which are going to be without membrane. I'm told that new electrolyzer are being designed without a membrane. Now, and in an electrolyzer, if you take only an electrolyzer, there's so much of R&D which is required to be done. How do we improve it overall? Goal is to reduce the cost. Look at the overall goal, but that's the kind of thing that we have to do. So R&D is going to be very important for us. Then you need to framework of regulations, codes and standards. It's not simple to just go ahead and do it unless we lay down together what is required, what are the standards for production, what are the standards for storage, what are the standards for transportation. Everybody must get together in forming those, and the world is doing it. It's not that India is doing differently. The world is doing it. In fact, in India, I must mention that we've already adopted. We have a committee steered by Secretary MNRE, which has different ministries. And we've already sent 94 recommendations on the standards, which we have collated, which our committees have worked on. recommended. We have already recommended 94 standards to the agencies like BIS, PESO, OISD for adoption. And out of this, 65 standards have already been published. So it's not that we haven't in 1 year time, last 1 year and 3 months. Now 65 standards have already been published, and the others are on the way. And therefore, but this is again a beginning. What we did was we said, okay, let's take on the priority wise. So let's take the most important ones, let's recommend them first, and then follow up on the other. Now we have gone on to the second set of recommendations, which we are going to finalize shortly, and then sending it. So it's going to be a continuous process. The world is also doing it. We have international standards. We are looking what is possible, whether we can adopt it in toto. If not, can we adapt it to Indian conditions? And in fact, I must tell you that few standards have been made only for India, because, for example, there is no standard for a two-wheeler, green hydrogen utilization in a two-wheeler, which we have formulated. Our teams have done it. And therefore, that's the kind of, we have to look at the entire aspect. In addition, then of course the pilot projects, as was mentioned, when we were formulating the mission, our 5 million metric tons is our target, and of course the main goal is for India was exports, because we want it to be a global hub for green hydrogen. But you cannot, you still have to decarbonize parts of our economy. So many industries, as was mentioned by Dr. Mathur, is a hard to abate sector. How do we allow green hydrogen utilization in various industries? And in our estimate, more than 90-95% of hydrogen used in India is used by refining sector and the fertilizer sector. These are two big sectors. Apart from that, hydrogen is also being utilized in various forms in the cement, in chemicals and petrochemicals, plastics, several other industries, steel, several other sectors which are utilizing it. But bigger sectors were refining and fertilizer. So we are focused on that. But for the hard to abate sector, which is steel, long haul mobility, which is trucks and buses, EVs are very good for SUV, small cars. You can easily electrify. You can have now cars which can go up to 300 or 400 kilometers with a single charge, I'm told. But at least it's easier. But for a bus or a truck, can we have those? If we cannot electrify them through a EV, then what do we do? So therefore, hydrogen is likely to be used for the long haul mobility. For in steel, long haul mobility and shipping. Shipping is another sector where there's a lot of scope for decarbonization. So can we, now shipping sector is looking at re-engineering its engines on utilization. Can it utilize straight green ammonia or a green methanol? Both are being looked at, and see whichever engines, of course both have been developed, but let's see which take off first commercially. And the International Maritime Organization has set a goal for the next 35, I think another 10 years or so, that they want to decarbonize most of the ships, convert them to either a green methanol or a green ammonia. So therefore, there's a huge industry out there that we need to set. And to start that process in India, we have, as part of the mission, pilot projects in steel, in long haul mobility and shipping. 3 pilot projects, 3 fields where we are doing pilot projects in the next 2 to 3 years, 3 to 4 years, and then we will go on the commercial level. So as part of our mission focuses on pilot projects in these 3 areas, these 3 fields, and of course in utilization of green hydrogen in refining and fertilizer. Just to comment on what was mentioned earlier, just to clarify, green hydrogen is not necessarily going to be used as a source of energy. It can be used in both ways. It can be used as a source of energy, but it can also be used to decarbonize and process. And therefore, it could be used as a feedstock to decarbonize the process. And therefore, in refining and fertilizer, for example, the green hydrogen is going to be used in the refining process as a replacement of grey hydrogen. the grey hydrogen is already being used in that process, but now the green hydrogen is going to be used. And of course, in fertilizer, we are already importing a lot of ammonia, grey ammonia for making fertilizer. We want to replace that grey ammonia with green ammonia. Simple. And then green ammonia is then going to be used for making fertilizer. So we are going to look at these as green hydrogen, largely going to be used in the refining and fertilizer sector in India. However, for the long haul mobility, is definitely is going to be a source of as a source of energy, because we're going to use fuel cell, and that's how we're going to power the trucks and buses. We are also going to use green hydrogen. Is going to be used for you through fuel cell, giving us power where otherwise it is not possible. For example, green hydrogen is going to be used as a storage, for which could be then utilized to power our electricity late in the evening. Again, a pilot we're going to do on that aspect as well. Overall, but however, green hydrogen by itself, production of green hydrogen would require renewable energy to come up. Our estimate is that 5 million metric tons of green hydrogen is likely to need about 100 to 125 gigawatt of additional RE capacity in India. And that is going to help us in reaching our goal of 500 gigawatt. The overall, I mean, just mention some of the other developments. In the incentives part, we have already, electrolyzers, we had come out with the tranche 1 bids, which we have allotted to 8 companies. So 1.5 gigawatt per annum capacity has been awarded to 8 companies, and 3 years is the target for starting the manufacturing. Tranche 2 bid has also been released, about 1.5 gigawatt. Again, that is closing in the next few days, and then we want to award that capacity. So overall, we are going to incentivize 3 gigawatt per annum of capacity per year is our target, which is our incentive can fund. Second is, of course, on the green hydrogen production incentive. That also we came out with a tranche 1 for 450,000 tons of green hydrogen. We have allotted it to 10 companies for about 412,000 metric ton per annum. And the reason why I didn't allot the entire thing is because we had kept a bucket for production through indigenous technology, and therefore we wanted a bucket, and 50,000 ton bucket we kept, and out of that we could only allot 12,000 because we want to incentivize the electrolyzers with technology made in India, and that is one of our another goal to as part of our mission. So that we will allot as soon as now the bids will close. In addition, on the demand side, now another aspect which we're going to, I believe, discuss anyway later during the day is the demand. How is demand going to be generated? So what we have done is we have built in an incentive under our scheme, and we have asked refineries, public sector refineries, to decarbonize their own individual processes by setting up green hydrogen plants adjacent to each refinery. That is the target that we have, and we will be given incentive for the production which happens there, and then all the refineries are coming out with bids for setting this up on that basis. Fertilizer industry is a little different. Fertilizer industry needs ammonia. So for that, it doesn't matter whether you can have one or two green hydrogen facility making ammonia and then supplying to different fertilizer companies in India. Transportation of ammonia is not a problem. So there we are doing a demand aggregation. We have about 500,000 tons of ammonia, which is currently the fertilizer industry companies have said that they need. We are doing we have done a demand aggregation. We will coming out with the bids for that capacity, and therefore we expect the green hydrogen producers to then bid for it, and then also set up facilities to provide that ammonia. Again, that ammonia is a little limited. I mean, compared to what we are importing, you must be wondering why it is such a small extent. And the reason is that the fertilizer sector is going to see some change. nano fertilizer is coming in, and therefore everybody is not yet certain of what certain about how much of gray ammonia or green ammonia would be needed in about 5 years time or 10 years time. So there is a little uncertainty about that. However, at least we are starting that process for demand aggregation. On the there's another aspect that we just want to highlight. Green hydrogen production is ideally going to be coming up near the utilization sector because it's difficult to transport, so it's to reduce the cost of transportation for the technical part, and therefore it's going to be near. So likely they are going to be set up near a port for export or near a utilization sector or like a refinery or a chemical plant and so on and so forth. So we expect that to happen. So what we are calling that production and utilization sector, we're going to call it a hydrogen hub. That's the title we have given under our mission. That again we have come out with scheme guidelines. We're going to support setting up of 2 such hubs in India. That's on the what we will incentivize. However, there are likely to be many more hydrogen hubs in India, because wherever green hydrogen production happens and utilization also is next door, that itself will become a hydrogen hub in some way. But we are trying to figure out how do we encourage them without incentive also. That's something that will be coming up. In addition, last thing just I wanted to mention that for export purposes, it's also important to see what are the advantages for the importing nation, and therefore we are also looking at tying up offtake agreements. Having a tie-up with a bilateral country under Article 6.2 of the Paris Agreement, which allows passing on the credits which are generated by using green hydrogen to the other country if it's on a bilateral basis. That is allowed under the Paris Agreement. We are looking at tying up bilateral agreements with some of the other countries. Let's see how quickly we can finalize those agreements. And last thing I must mention, one, it's important for government to announce a mission. It's important for government to roll out the incentive program. But most important is whether the industry is biting. Is the industry on board? Do you think that the sector is confident about the mission, success of the mission that the government has launched? And I must just add here as a last point that since we launched the mission, the green hydrogen industry, the industry in India has already announced projects for production with a production capacity of about 7.6 million metric tons per annum of green hydrogen by 2030. And that shows the confidence that the industry has. Part of it would be, they could be covered under some incentive that we have rolled out, but not necessarily. In fact, I must tell you that 2 companies bid in our tranche 1 of green hydrogen production incentive with 0 subsidy. And we were also surprised. Why? You want to be covered under the mission, under the targets that you are taking, but you don't want an incentive. They said no. We just want a recognition of being part of this mission, because it will help us somewhere. It will help us maybe in the financing part, it will help us something else. We do not want a subsidy, we just want to be as part of the mission. And that's the kind of, so that's just to, that just shows the confidence that the industry has on this success of the mission. But again, this is not without challenges, and I think what ISA and INAE plan to do today is going to be very important, because all these aspects need to be worked out in detail. We are always looking at suggestions. On the ground, there's of course several challenges, and the challenges are largely banking of energy. When there's huge capacities of RE coming up, the state and largely these is solar and wind, and if solar is going to be only in the solar hours, a lot of banking would be needed by the industry is going to be producing electricity and supplying, and therefore, and that kind of banking the state must be capable of providing. because it's not simply to say, please provide. States must have the capacity to give back that energy in the evening. So therefore, banking is one aspect. Of course, land and other issues are the second aspect. Of course, third is the offtake agreement, because financial industry is still new to green hydrogen. It's not easy for everybody to get financing at the moment. So they are, that's again a confidence building measure that we are doing with the financial institutions as well, that this is how the mission is there, this is the project, this is going to be the project, this is going to be the RE, this is the technology. So please have confidence and lend to the sector. That's just one of the challenges. I mean, there's several other aspects of the mission that I have not talked about, but it's a very comprehensive mission, mission-oriented approach that we have taken. We are confident that we will succeed, but we continue to work toward it, and with the help of ISA and of course INAE in your deliberations today, I think it will be useful for us. We are also confident that ISA will be taking forward the Green Hydrogen Innovation Center. We want to roll that out across, so that it becomes a reference point. It should become the first top, reference point for green hydrogen information, database, and otherwise for people to follow. And I think we've already started on that path, and we hope to do that as well. Thank you so much for inviting me, and all the best for today's deliberations.
Thank you, sir, for providing deep insights into the Indian Green Hydrogen National Mission, and also mapping the overall ecosystem of green hydrogen, covering the entire value chain. This sets the stage for meaningful discussions in today's seminar. Sir, ladies and gentlemen, as we conclude the inaugural session, as a token of appreciation, I would like to request DG ISA to please present to our honorable guests the souvenirs. We'll start with Secretary MNRE. Professor Indranil Manna, please.
So heavy and so big, huh?
We have Mr. Pradeep Chaturvedi. Mr. Pradeep Chaturvedi. Mr. Manna, yes.
Chaturvedi. कर दिया
Particularly,
मेरा भी नाम है.
I would request Colonel Rai. Ladies and gentlemen, please allow me to request Colonel Shobhit Rai, officiating ED, INAE, to give vote of thanks.
Respected Chief Guest for today, Mr. B.S. Bhalla, Secretary, Ministry of New and Renewable Energy, Government of India, distinguished guests, panelists present in person, and delegates present online from India and abroad. On behalf of Indian National Academy of Engineering as Officiating Executive Director of INAE, it is my privilege and honor to present the vote of thanks. My gratitude to the hosts for today, Dr. Ajay Mathur, Director General ISA, Mr. Chaturvedi, Chairman Delhi Chapter, for kindly consenting to be host for today's event. It's indeed an honor for me to have amongst us three former presidents of INAE, none other than Dr. Anil Kakotkar, Dr. B.N. Suresh, and Dr. Sanak Mishra. Amongst us, we have Professor Indranil Manna, President INAE, Professor U.B. Desai, Professor Sivaji Chakravarti, and Mr. J.D. Patil, our esteemed Vice Presidents, and learned fellows of INAE who join us online. There are experts from various ministries, industries, academicians, and experts from abroad. My gratitude to all of you for consenting to be part of this seminar by sparing your valuable time. Lastly, my gratitude to the complete team of International Solar Alliance, Dr. Mridula Bhardwaj and her colleagues from ISA, and my colleagues from INAE, to draw out very carefully this day-long seminar on green hydrogen. Thank you and Jai Hind.